Alrighty. So we're looking at number 5. We got lots of things to find first. So, is there a hole in this graph? No. Why is there not a hole in this graph? Nothing cancels. Alright, now notice I wrote none. I did not write NA. You guys know what NA stands for? Not applicable. Is it not applicable to even ask about a hole? No, it's totally applicable. We should always ask. So that's the reason I'm saying none.
Do you have a hole?
So there's not a hole. What about the vertical asymptote? So x equals -1. And then I'm going to go ahead and jump down and draw that on my graph. Alright, x-intercepts. So we've got one at 2 and one at 1. And we can graph those. So if there's an x-intercept at 1 and an x-intercept at 2, what must have happened in between those points? Up or down, yeah. It must have gone, these curves are going to be smooth. It must have gone done like a little bloop underneath. So that means we do have a minimum for this graph, and it's somewhere in between 1 and 2. Okay.
7.
All right. Yeah, definitely 7. Horizontal asymptote. None. What does it mean if there is no horizontal asymptote?
It's like vertical.
Not vertical. It means there's a slant or oblique, however you want to say it is fine. This is what we're going to use our ruler for. So finding a slant or oblique asymptote, that's something you're going to do in pre-calc. We might not be finding it by hand, but we're still going to be able to see where it is on the graph. So the reason I gave you guys transparent rulers is because we're going to draw in the slant asymptote. And if you guys remember how asymptotes work, the curve gets closer to them. So we want to figure out where our slanted line should be so that you can see that the curve on the top is getting closer to it and the curve on the bottom is getting closer to it. You guys see that? How I'm making my slant like right there? Okay. So we're going to put our ruler there and we're going to line it up as best we can. And then we're going to draw our slant asymptote.
Okay.
So you just got to line up your ruler. That's why you've got a see-through ruler. Okay. So your slant should look something like that. So your slant asymptote looks like? Our slant asymptote should not be right here because the curves don't get closer to that. That would be a silly slant asymptote. So we should always draw the slant asymptote so that the curves are getting closer to it on each end.
Yep.
All right. Now, when you have a slant asymptote that looks like this, it means that even though this picture doesn't have like a really deep valley to it, it definitely goes down and comes back up. I can see that because if I look at my asymptote and I can see that it's going further and further and further, then I know this is definitely making a U shape. Does that make sense? So we definitely have a minimum. Over here, when I see my slant asymptote, I can definitely see that even though it doesn't look super steep right there at the top, it's definitely, big picture perspective, it's going to be a mountaintop. Okay? Because this asymptote is bringing this line back down. Okay? So this time, we definitely have a max or a min that we have to look for. Okay? All right, y-intercept. What's the y-intercept? All right, let's go ahead and find our max and min. So we do need calculators. So I'm graphing this. Now, the nice thing about this assignment is since all these graphs have been graphed for you already, it kind of gives you a clue about how big you can make your window so that you can see everything. So I can see from this graph paper right here that my window might be best if I do from -6 to 6. So I'm going to hit the window button, and I'm going to change this so it's -6 to 6. That's because I'm making it match my paper. Alright, so we are looking for a minimum somewhere right in here. I can't see it very well with my eye, but I know it's there.
Making it 6.
So, second trace, yeah, I made it 6. Second trace, minimum, number 3. Now you can kind of tell where minimums are because you can watch your X and your Y coordinate. So as you're scrolling to the left and right, you can watch the Y value and see when it goes down and see when it goes back up again. So I'm going to use this as my left bound, and then I'm going to hit the right arrow, and I'm just watching my Y. I can see my Y value went down, and then it went back up again. Everyone see that?
Yeah.
So that means I'm on the other side of the minimum, so I'm going to press enter. Yeah, 1.449. I'm going to go ahead and write this minimum down.
Oh, what?
How'd you do it again? That's right, second trace.
Second trace, number 3.
And we scroll up to
So second trace, number 3. I started with my left bound. Did you get it?
You mean number
Yep.
4?
Okay. So now we'll go ahead and do the maximum. So I'm going to do second trace number 4. Same thing for this one. I want to go over to the other curve, so I'm going to hold it down left for a while. And what we're going to do is we're going to start it where it's definitely like this is definitely a little bit lower than that part. So I'm going to press enter. And then as I go to the right, I'm just going to watch that Y value, and I want to see the Y value go up, and then I want to see it go down again, and that tells me I'm on the other side of it. So I watched the Y value got to like -2.4 was the least negative number, and then it was -2.5, -2.6. That tells me that it's going back down again, so that means I'm on the other side of the maximum. And so there's our maximum right there. We'll go ahead and write that down. And we'll go ahead and add that to our picture. All right. So we can do the domain without even looking at the graph, right?
Yeah.
So what is our domain? Mm-hmm. -1, 2. We only have to skip the bottom number, right? So we just have to skip -1. We don't have to skip this one because it doesn't have an X with it. So we only worry about the bottom. We're only skipping -1. So that means it's -infinity to -1, -1 to infinity. I'll finish. All right. So this one for the range, we have to be real careful. So in the range, where do we start looking in the picture? The bottom. We go down to up. And we do down to up because we want the smaller numbers to be written first. and negative infinity is the smallest number that you can imagine. So down. So what number do we start with?
Negative 2.4.
Yeah, so negative infinity to the y coordinate of this maximum. We have to use the y coordinate because the y coordinate is what tells you up and down. So we've got negative infinity up to this y coordinate right here. And once we write that, does this get a bracket or a parenthesis? Bracket. It's an actual point on the graph. And then we've got some space right here in the middle where no y values happen right here. So the y value of negative 2 is not on this graph. A y value of negative 1 is not on this graph. What is the next smallest y value?
Negative 0. 0.2.
Yeah, it's this one right here. It's the minimum. So we skip all these. We have the maximum, and then we skip all these, and then our next y value is that minimum. So I'm going to say u, and then negative 0.025. And what should I have around this?
Infinity,
a bracket. And then it goes to infinity because it goes up forever. So this time we didn't have a horizontal asymptote to worry about. We didn't have a hole to worry about, but the maximum and the minimum did help us with our range. So those did make a difference. All right, increasing, decreasing. Go ahead and do those. So I'm going to draw my little stick figure guy. Can you guys see this color okay?
Yeah, we're good.
So what is the x value right here at this left arrow? Negative infinity. And what is he doing?
walking up.
He's
Increasing. Okay. And then he hits this maximum.
And it drops.
And then he's going to be going down. He's decreasing. And what is the x value at this dotted line?
3.44.
Negative infinity?
No, the x value.
Oh.
Negative 1. The x value right there is negative 1. Okay. What was the x value at the dot?
That just 3.
Yeah, it's this one right here. So this is the one that we're using right here. Okay. So he runs down here, and then what happens to him? He dies. All right. So we're done with that. And then we start a new stick figure, and he goes up here on the left side because we're Americans, and that's what we do. And what is this x value right here again at the dotted line? Negative 1. All right. So what is this stick figure doing? Decreasing. All right. And then he hits the blue dot for the minimum. And we're going to use the x value, yep. And then he starts to increase after that. And what is the x value of this arrow? Infinity. Infinity. The x value. We're thinking the y value. It is tricky.
So it'll be negative 30 to negative 3.49.
Yeah, so let's, which one are you're doing increasing? Yeah, so negative infinity to negative 3.449. 1.449 to infinity. Okay. So there's our two increasing intervals. And then what about decreasing?
Negative infinity to 3 points.
To negative 1.
So we always go left to right. So we start with the negative 3.449 to negative 1. And then we have
Negative 1 to 1.449.
okay. And then what do we put for constant?
None.
None. All right. Let's go ahead and flip back to number 4. You guys need to see this for a while, or did we write it all down already? You got it? Alright, so what I want us to do on this one is, all I want us to do is look for the horizontal asymptote. So what do you see when you look for the horizontal asymptote? You see, for number 4?
None?
It's none. Horizontal asymptote, none. So what does that mean instead?
No cancel.
Say it?
Oh, we talking about horizontal asymptote.
Yeah. Oh, you were saying that.
Yeah, I was saying that.
Yeah, you were starting at the beginning. So for this one, no horizontal asymptote. What does that mean instead? Yeah, there's a slant asymptote, oblique asymptote, whatever you want to call it. So let's go down and let's draw it.
No.
So in the last picture we had for number 5, the slant asymptote is what made it so the curves had to have a max or a min. The slant asymptote pushed the picture to go a certain direction so that it would have those. Are these curves going to have a max and a min just because they have a slant? No. What's going to happen this time? None, right? Because it goes down and then it just keeps going down. The slant asymptote does not force it to go back up. Now, if this slant asymptote had gone this way, then the curve would have gone down and gone back up, and it would have definitely had a minimum. And this, yeah, and the other curve would have gone down, it would have had a maximum. Okay, but because the slant goes this way for max and for min, we're going to say none. So when you look at the problems that have a slant asymptote, you have to be careful. They don't always have a max or min. You have to figure out if it's a problem that looks like number 4, where this one's going down and it still goes down, and this one's going up and it still goes up, or if it's a problem like number 5, where the slant asymptote actually made it have a max or a min. Does that make sense? Okay.